Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the NEET 2025 questions of 12th NCERT Part 1. That means from the chapter electric charges and fields to the electromagnetic wave. Okay, so let's go through the questions. So here you can see the first question is from the chapter electric charges and fields. Let's go through it. Two identical charged conducting spheres A and B have their centers separated by a certain distance. Charge on each sphere is Q and the force of repulsion between them is F. Okay, now a third identical uncharged conducting sphere is brought in contact with sphere A first and then with B and finally removed from both. Okay, new force of repulsion between spheres A and B, and here what they are considering here, the radii of A and B are negligible compared to the distance of separation, so that for calculating force between them they can be considered as a point charges. Actually they are telling they are which kind of situation is there, point charges are there. Okay, because you know very well Coulomb's law applicable for the which kind of situations, maybe spherical charge distribution or maybe point charge. Okay, so this is the question may be looking somewhat long, but answer will be very easy only. So here is between them, is it? So let's go through the question. So here you can see very well, on each sphere of A and B how much charge is there. The charge is given here Q. Okay, so I can write here, see I can write here initially the charge on sphere A and the charge on sphere B, how much is given here, Q. Okay, and I can write here, this is the situation like this. Initial situation we are doing here, this is, let's take here Q and this is also Q, is it? And the force of repulsion will be there here F, and here also how much here, F. And separation between them, how much is this? Let's take separation between them is R, and they are placed in a air. Okay, they are placed in a air. So you know very well in this situation what is the force from the Coulomb's law in a air means it is given by 1 by 4 pi epsilon naught into Q1 Q2 by R. So here Q square by R. Now this is equation 1. Now what is happening that here we have another identical kind of body C. Okay, and initially charge on the C, how much here, initially the charge on the C is 0. Okay, so what will happen that here when this C will come in contact with this A, when C will come in contact with A, so when C will come in contact with A, what will happen, as both are point charges, the charge will be distributed equally. Okay, so what this will happen that here, new charge QA dash and Q2 dash is given by, remember that here 0 and here QA how much here, Q, so it will become here, remember that here Q plus 0 by 2 and it will become here Q by 2, is it? So charge on A after the contact, how much is coming here, Q by 2. After that what is happening that here, this C is coming in contact with B also. So in this situation what will happen that here, QB dash or new charge on the sphere C will be given how much here, remember that here charge on the B how much, you know very well Q, is it? And charge on the C how much, when it came in contact with A, how much charge it has got, it has got charge Q by 2, this also, so it will become here Q plus Q by 2 by 2. So when you will simplify this, it will come here, what's here, 3Q by 2, is it, by 2, so it will come here 3Q by 4. Okay, but our point of interest is that the charge on sphere A is how much here, finally Q by 2, and charge on the sphere B also, not also actually, how much coming here, 3Q by 4. Okay, now what will happen that here in a new situation, now I will write here the new situation is this. Okay, and now the new charge is Q dash how much here, Q by 2, I will write here Q dash, and here how much here, QB dash, and now they are separated by same distance R, is it? And you know very well both the charges are positive, so repulsion will be there. Let's take new force is F dash. Okay, so now this new force F dash is given by what, again see here 1 by 4 pi epsilon naught into charge how much is, charge how much here, Q dash how much charge it is got, Q by 2, and QB dash how much charge it has got here, 3q by 4 by r square, is it? Now after that you can see very well, it will become here 3 by 8 and it will come here 1 by 4 pi epsilon naught into q square by r. And you know very well from equation 1 I can write here f dash is equal to 3 by 8. What is this? This you can see, this is the f. Okay, so f dash will become here what here 3f by 8, is it? So kindly see very well how we have done this now. So which option is correct here? The correct option is here 3f by 8. Option D is the correct answer. And remember that here, whenever two spherical bodies on point charges having charge q1 and q2 is coming in contact, then the final charge on both of them will be equal, and that is how much? q1 plus q2 by 2. Okay, applicable for the spherical and point charge bodies here. Now next one after that, see here, electric potential and capacitance question is this. See the question. Question is, an electric dipole with a dipole moment, this is aligned with the direction of a uniform electric field of magnitude this one. Okay, align in the direction. Now the dipole is then rotated through an angle of 60 degree with respect to the electric field. The change in the potential energy of this dipole is how much here? Okay, so first let me note down the data is. So the dipole moment P is given, how much is this? Kindly see 5 into 10 to the power minus 6 coulomb meter, is it? Electric field, how much is given here? Electric field is given here 4 into 10 to the power 5 Newton per coulomb. Okay, and first what they are telling that here, initially they are telling that here in the same direction, dipole moment in the same direction of the electric field, so theta 1 0. After that it is making how much angle? After that it is making angle here 60 degrees. So theta 2 how much here? 60 degree. They are asking what? They are asking the difference in the energy u2 minus u1. Okay, so what will happen that here? See you know very well, as potential energy formula, can you see here? U equal to minus Pe cos theta. Theta is the angle between dipole moment and the electric field. Okay, so from here if I write here u2 minus u1, so u2 minus u1, what this will become here? Kindly see, minus Pe cos theta 2, no, minus Pe cos theta 2. This is u2. u1 how much here? Minus Pe cos theta 1, is it? Now if I will take Pe common here, it will become here, kindly see here, cos theta 1 minus cos theta 2, is it? That is the potential energy difference. Now after that let me put here the values, is it? So P how much here? 5 into 10 power minus 6, and this you multiply. So 5 into 4 20, I am multiplying just 10 power minus 6 into 10 power 5 means it will become here 10 to the power minus 1, correct? 5 into 4 20, and this multiplication, is it? And after that cos theta 1, cos 0, cos theta 1 means cos 0 1 minus cos 60, cos 60 how much here? Cos 60 how much here? 1 by 2, is it? Then after that let's simplify this. It will become here 20 into 10 power minus 1 means 2, and 1 minus 1 by 2, it will become here 1 by 2. 2 and 2 cancel. So how much it is coming here? It is coming here 1 joule. Which option is correct here? The correct option is here option B. Okay, very easy. This formula minus P cos theta is this. Even you can write here in a vector form, vector P dot vector E also, is it? Great. Let's see the next question from the, again the chapter is same. So see, the plates of a parallel plate capacitor are separated by D. Two slabs of different dielectric constant K1 and K2 with thickness 3D by 8 and D by 2 respectively are inserted in the capacitor. Due to this, the capacitor becomes how much given? 2 times larger than where is nothing between the plates. If K1 equal to 1.25 K2, the value of K1 is how much here? Okay, so remember that here what is the situation when only like this thing is there. Now first this is the initial situation, this capacitor is there. Now because A I will use for the area, so I will write here the terminals M and N. Now M and N, and here what is present here? Here air is present. Okay, so in this situation initially, see initial, what is the formula here? If only air is there, I can write here epsilon naught A by D, is it? This is the formula. After that what will happen that here? Make sure that here this capacitor is there. Now this is the capacitor, this is the capacitor is there Mn. Now and anyhow the separation between them, how much here? The separation between them is d. Okay. Now what is happening that here they are putting the dielectric. Dielectric. One dielectric of thickness how much here? 3d by 8 and another one is d by 2. Okay. So first let me put this dielectric is this. This is. Let's take here this I put here d by 2 and after that one more dielectric is this. Is it this one more dielectric, and this is how much here? This is the 3d by 8. How much here? 3d by 8. This I am telling dielectric 1, okay, for solving purpose. This I am telling for dielectric 2, because in the question first they talk about this one, then they talk about this one. So remember that here in this situation, what is the formula? Remember that the formula will be how much here? C final epsilon naught A by 2 dielectrics are there, na? Thickness. Let's take this is T1, this is T2. So remember that here D minus T1 plus T2 plus T1 by K1 plus T2 by K2. Now this formula I have to use D minus T1 plus T2 plus T1 by K1 plus T2 by K2. Okay. Now after that let me write here. Okay. So see here this CF is equal to how much here? Epsilon naught A by D minus. Now T1 plus T2 how much here? See here D by 2 plus 3D by 8. T1 means, as I have told you very well, T1 means 3D by 8 plus T2 means what is this? D by 2. Okay. Even you can interchange also T1, T2, no problem will come. Plus T1 by K1, that means 3D by 8 K1. Is it? So see here. 3 by 8 K1 here. Okay. Because see here please, this is given here, this is given K1. Okay. And this is given here K2. Okay, so we can't interchange it. No? So 3D by 8 K1 and after that what will become here? C plus D by 2 K2. Is it? We are doing correct? D by 2 K2. Now first we'll simplify this, then we'll make it twice. Now, so what this will become here? Kindly see here. This CF equal to, it will become here C epsilon naught A D minus 3D by 8 plus D by 2. Take the LCM. When you will take the LCM here, 8 for example. You have taken here the LCM 8, so it will become here 3D plus 2 4 ja 8, so here 4D, is it? And plus what will become here? Kindly see here 3D by 8 K1 plus D by 2, and K2 value how much is given here? See K2 equal to 1.25. K1 value is given here. K1 value is given what here? 1.25 K2. Okay, K1 value is given here. K1 value is given here 1.25 K2, but in the question they are asking K1 only. Okay, so what I will do here, this K2 value I will put from K1. Okay, so what I can write here, this is as it is same plus D by 2, and from here K2 will be how much here? If you can see here, K1 by 1.25. K2 how much? Can you see here? K2 is how much here? K1 by 1.25. So we can write here K1, and 1.25 means 125 by 100. So we can write here 125 by 100. How much here? 5 by 4. So we can write here 4 K1 by 5. Correct? 4 K1 by 5. Is it? So here I am writing here, see, this is 4 K1 and 5 will go up. Okay, because I have to find out K1 now. Is it? So this thing we have got it. Is it? Now after that, you know that according to question, what is given here? Kindly see here very well. The capacitance, the new capacitance becomes 2 times. The new capacitance becomes how much? 2 times. Is it? So remember that here, new capacitance, that means CF is equal to 2CI is given. Is it? CF equal to how much? 2CI. Is it? Now CF how much here? See, epsilon naught A by D minus, I am solving this here, D minus, it will become here 3D plus 4D, 7D by 8, 7D by 8, okay, plus 3D by 8 K1, is it? As I remember, 3D by 8 K1, what this will become here? 5D by 8 K1, 5D by 8 K1, so see here please, plus 5D by 8 K1 is equal to 2 epsilon naught A by D, is it? Now we have to just simplify this here. Epsilon naught A cancelled, is it? So kindly see here, 1 by, I have taken here D, constant outside, so 1 minus 7 by 8 plus, D is outside, na, so 3 by 8 K1 plus, I can write as C, 5 by 8 K1 is equal to 2 by D. D and D also cancel, is it? That means I can write here, kindly see here students, it will become here 1 minus 7 by 8 means how much here? 1 by 8 plus 3 by 8 K1 plus 5 by 8 K2. Now let me check here. 4 into 2, it is coming now. Okay, it is coming here and is equal to 2. Is it? Now we have to simplify this. Whatever way we can simplify here. Is it? But this is just take here 2 by 1. Is it? So let's do here the cross multiplication. Now I have done here the cross multiplication. So okay, this we can send this side. See, this I can this side here. Okay, so what this will become here? See, 2 times, and here it will become here 2 by 8. Anyhow, 8 is outside. So 1 plus 3 by K1 plus 5 by K1. 5 by K1. See here K1 is this, na? K1, 5 by K1. So anyhow, what is this? Is a K1 here, is it? K1. So 5 by K1 is equal to this 1 into 1, cross multiplication 1. Now we are going like this here, is it? Little bit calculation is this here. No? So what this will become here? Kindly see here, 2 by 8 means 1 by 4, and here 1 plus 3 by K1 plus 5 by K1 means 8 by K1 is equal to 1, is it? So what we can write here, see here, 1 plus 8 by K1 is equal to 4, is it, students? So can you see here, 8 by K1 is equal to 4 minus 1, 3, is it? So what will come here? K1 is coming here. What is the students say? 8 by 3. So 8 by 3 means it will become here 2.66, is it? Can you see very well? Now like this we have to do the calculation. Okay, this time question paper came somewhat little bit tough. So see here, option A is the correct answer. New capacitance, final capacitance, somewhat we have simplified. The Q2 value we have replaced from here, and then we have got the answer. Is it? Great. Next one after that, we are going to this question here. See, the current passing through the battery in the given circuit is, and these options are there. So when you will see the circuit diagram, you can identify very well. This is water, this is the Wheatstone bridge. How can I tell that Wheatstone bridge? Kindly see very well here, is it? So see this I have identified the points here. See, so if I am writing here, see, this is the P for example, this is the Q, this is R, this is S. So when you will see P by Q, P by Q how much here? 5 by 2.5, is it? 5 by 2.5. And R by S how much here? R by S here 3 by 1.5. So you can see 5 by 2.5, 2, is it? And this is also how much here? 2, is it? That means this is the balanced Wheatstone bridge, and in case of balanced Wheatstone bridge, what will happen that here? This we can remove it, this we can remove it. Okay, so when we can remove this, what will happen that here? Kindly see here, this I am going to remove this, is it? Because as I have told you now, this can be removed here. Okay, so when we will remove this, you can see very well. What you can see very well, students, see, this and this in series, this and this in series. So 5 and 3 series, how much here? 8. And 2.5 and 1.5 also in series. 2.5 plus 1.5, 4, is it? So here I can write here this R. This R is coming how much here? 5 and 3 in series, 8. And 2.5 and 1.5 in series, 4. 8 and 4 in parallel means R1 R2 by R1 plus R2. So 8 into 4 by 8 plus 4. How much is coming here? 8 4 is 32 and 8 4 is 12. Okay, simplify this more. 4 3 is 12, 4 8 is 32. So 8 by 3 ohm. Now after that, see here this R equivalent. Now what will happen that here? See, this one, this overall will come in series with 1.5, 5.5 and 1 by 3. Okay, so what we can write here? See, 8 by 3 plus, see digit, 1.5 plus 5.5, how much here? 7 plus this 1 by 3 is also there, is it? All of them will come in a series. Now take the LCM, 3 here. So this is 8, 3 times, 3 7 is 21, and here how much here? 1. So what this is coming here? Kindly see here, 30 by 3, 30 by 3, 30 by 3, how much coming here? 10 ohm. That means equivalent how much here? Equivalent 10 ohm. Now this 10 ohm is connected across the battery here. Now this is the battery. Now across these terminals, this 10 ohm is connected. So what is the current? The current is given here, I equal to V by R equivalent. That means 5 by 10. is it? So 5 by 10, how much is coming here? 0.5 ampere. 0.5 ampere. Which option is correct here? The correct option is here. Option B is the answer. This question is based upon the application of the Redstone bridge here. Okay. Next one. Kindly see here. See, the question is, a wire of resistance capital R is cut into 8 equal pieces. From these pieces, 2 equivalent resistances are made by adding 4 of these together in parallel. Then these 2 sets are added in series. The net effective resistance of the combination, how much here? Okay. So the question is what? One wire is this. Let's take this is the wire. Now this is the wire is this uniform. Now resistance is distributed uniformly. Resistance how much here? R. Okay. So what will happen that here? When this wire is cut into 8 parts. So when this wire will cut into 8 parts, then resistance of each part how much here? Can you see resistance of each part? Yes and tell. Resistance of each part will be R by 8. Is it? R by 8. Now after that here, this they are connected in parallel. How many are connected in parallel? 4 of these together in parallel. Okay, so I will just draw here the circuit diagram. I'm just drawing here. What I'm drawing here? Circuit diagram, circuit. Okay, so that you can see very well here. This wire is this, but I'm just drawing here just like a circuit diagram. See here. This is one wire. This is one wire. This is one wire, and this is 4 wires are there connected in parallel. Then after that, what is happening that here again 2 sets we are making here. Now like this. These 2 sets are there. Is it? This is 4, this is 4. And but these 2 sets, this is one set, this is second set, they are connected in series. Is it? So what is the equivalent here? Kindly see here. Each of them R by 8. So this is R by 8, R by 8. All are R by 8 only. Is it? And here also, this here. Kindly see here. Is it? Same writing here. Now what is happening that here? See here. When R by 8 and R by 8 are connected in parallel. So you know when R and R connected in parallel, R by 2, is it? So R by 8, R by 8, R by 8, R by 8, they are connected in parallel, is it? So you know what will be there? It will be, equivalent will be R by 8 by 4, is it? And here also equivalent how much here? Remember that here R by 8 by 4, is it? Between point A and B. Then you know very well here what is happening. This and this are connected in series, is it? So equivalent is given here. R by 8 by 4 means we can write here R by 32 plus R by 32. So R by 32 plus R by 32, 2R by 32. And we can write a 2R by 32 means how much here? R by 16. So which option is correct here? R by 16, C. Now equivalent. This is also from current electricity chapter. Okay. Next one, let's see this question. This question repeated even in a JEE. Okay. JEE. Now number of questions of JEE even this year they ask in a NEET exam. So see, a constant voltage of 50 volt is maintained between the points A and B of the circuit shown in figure here. Okay, this is somewhere A and B is it? Now after that here, the current through the branch CD of the circuit is how much here? Now branch C and D is the shorted. Okay, so remember that here one thing. First I am going to calculate here the equivalent. How well? Even this question can be solved by the KVL also, but first I will just solve in a different way here. Okay, so see here please, I'm just writing here like this. See, this is this C and D is the sorted. No, so see, C and D is the sorted. Okay, and after that again I'm drawing here. See this one here, this one like this I'm drawing here. Is it? Like this we have drawn here. Put here 1 ohm, 3 ohm, here 2 ohm, 4 ohm. Okay, and from here one battery is connected. No, battery is connected here. Is it? So this battery how much here? 50 volt battery is there. Okay. Now after that what will happen here? Now can we find out the equivalent? Equivalent can we find out here? Tell me please. Yes. 1 and 3 in a parallel. So this equivalent will be how much here? If I write here this equivalent, R1 R2 by R1 plus R2, so it will become here 3 into 1 by 3 plus 1, 3 by 4. Is it? Here also what is this here? 2 and 4 is connected in parallel. So 2 into 4, 8. 2 into 4, 8 and 2 plus 4, 6. 8 by 6, how much here? 4 by 3 ohm. Is it? So this is coming here 3 by 4 and this is coming here 4 by 3 ohm. And now both of them are connected in a series. Is it? So this R equivalent is coming how much here? Remember that here, see 3 by 4 plus 4 by 3. Take the LCM please. LCM is coming 12. So 4 3 are 12, 3 3 are 9. and 3 4 are 12, 4 4 are 16. So it is coming here how much here? 25 by 12 ohm. How much is coming here, students? 25 by 12 ohm. Now current. How much current will come from the battery? From the battery current will come V by R equivalent. V how much here? 50. And here how much here? 25 by 12 into 12. So it will become here what? 24 ampere. How much current is coming from here? I. Remember that 24 ampere is coming from the battery. Okay. Now after that second one, I am going to use here the current divider theorem here. Okay. I am going to get the current here I1. I1. Let's take here this is R1 and this is R2. Is it? And total current I is coming. So remember that from the current divider theorem, this I1 is given by R2 by R1 plus R2. R2, that means R2 means 3 by R1 plus R2, 1 plus 3, and the total current how much here? 24. Is it? So this will come here, see, 3 by 4 into 24. So how much is coming here? Kindly see here. 4 6 ja 24, 6 into 3, 18 ampere. How much is coming here? This I1 is the 18 ampere. Okay. Next one after that, see here. This I1, I have got how much here? 18 ampere. Now after that, I am going to get the current here. Okay, I am going to get the current here. Let's take this current I have taken here. Let's take for example I3 I have taken. Okay, again you know very well 2 ohm and 4 ohm are connected in a parallel. Is it? So here I will use here the current divider theorem. I3 means this. Let's take this is the R3. This is the R4. So here what will become? I3 means R4 by R3 plus R4. So R4 means 4. R3 plus R4 means 2 plus 4. Total current how much is coming here? 24. Is it? So can you simplify this here? This will come here 4 by 6. How much here? 4 by 6 means 2 by 3 into 24. Is it? So what is coming here? 3 8 are 24 and 8 into 2 16 ampere. How much is going? 16 ampere. So remember that here what is happening that here this I1 is the 18 ampere and this I3 is coming here how much here? Yes, 16 ampere. 16 ampere. Is it? So see, 18 ampere is coming, 16 ampere went this side. So here how much will go? It will go here 2 ampere. Kindly see very well how we have done. No need to use the, if you want to use the KVL, okay, but I feel this much more comfortable. Okay, you can use the KVL also, no problem here. Okay, so see, anyhow this space we have used it. Next one, kindly see here students, this is the question from the moving charges and magnetism. So see the question is, an electron of mass this and charge this moving with speed c by 100 is injected into a magnetic field B of magnitude this one perpendicular to its direction of motion. We wish to apply a uniform electric field together with the magnetic field so that the electron does not deflect from its path. Then which option is correct? Okay, so this question is belonging to the chapter velocity selector. Okay, so in a velocity selector what happens that here, first let me remember here the value. B is given 9 into 10 power minus 4 here. See here, this B is given here what? 9 into 10 power minus 4 Tesla. Is it? And speed of the electron is given here how much here? C by 100. C value 3 into 10 power 8 speed of the light by 100, or we can tell 3 into 10 power 6 meter per second. Okay. After that what happens that here? Remember that here. Remember that kindly students. If in case this is a magnetic field. Okay. This is a magnetic field. Magnetic field is this. And what is entering here? Electron is entering the electron. So here this. When this is the electron is this. Electron is entering. Now with velocity v for example. So remember that here for the positive charge, the force acts along the direction of a v cross v. Okay, and for the negative charge, force acts along the direction of minus of v cross v because of negative charge, or we can tell here b cross v. Okay, so because of b cross v, b inside v this side, b cross v means the magnetic force will act in this direction. Okay, this is the magnetic force direction. Okay. What is this? This is the magnetic force direction. Then anyhow, electric force we have to apply in which direction? The electric field should be in this direction here. This is the direction of the, negative charge is this, negative charge. So negative charge means what will happen that here? Negative charge, what will be there? Electric field will be in which direction? This direction, downward direction. Now because of negative charge, all this story is there. Electric field in this direction will be there. Then only this negative charge will experience electrostatic force in which direction? Upward direction here. Okay, like this. So this is Fe, this is Fm. When both the forces will be balanced, it will go straight without any deflection. Okay, so remember that here, Fe is equal to Fb. Fe how much here? Remember that here, charge of electron into electric field. FB means QVB sin theta. QVB sin theta. So here EVB sin theta. Theta is the angle between velocity and the magnetic field. Velocity along x-axis, magnetic field along negative z direction because of inside. So it will come here a 90 degree. Okay. So what this happens that here, when you solve here, V will come here E by B. Okay. So we can tell E equal to BV. Is it? So B how much is given here? Kindly see here 9 into 10 power minus 4 into V how much here? 3 into 10 to the power 6. Is it? So 9 into 3, 27 into, it will become here 10 power 2 volt per meter or Newton per coulomb. Is it? So what is coming that here? 27 into 10 power 2 Newton per coulomb here. Okay, and this is the diagram here. So you can see here, students, see. So 27 into 10 power 2. This option is this option is. But here you can see each perpendicular to B and each parallel to B. You know very well each perpendicular to B. Why can I tell here? Because E along negative y direction, but magnetic field is inside negative z direction. Na? So y and z perpendicular. Correct option is here. Option B is the answer. Is it? Great. Great. So this thing we have done here. Now students, next one we are going to move for the further questions. Now, moving charges and magnetism question is this. So see the question. A 2 ampere current is flowing through two different small circular copper coils having radii ratio 1:2. The ratio of their respective magnetic moments how much here? Okay, and here the magnetic moment is coming because of the current. Okay, so what is given here? Kindly see here. Current is same in both the coils. Current is 2 ampere and that is constant in both the coils. Is it? You can see very well here. After that you can see very well radii ratio what is given here, R1 by R2, it is given here 1 by 2. Now, and after that remember that here the magnetic moment formula as M equal to NIA. Nothing is given, number of turns 1. Current is constant, so we can tell here M directly proportional to A. Okay, or we can do here one more thing. This step also we can skip here. NIA. So NI. Area, which kind of coil is there? Circular coil. So area of the circular coil how much here? Pi r square. Is it? See here. So Ni pi is constant. That means we can write here, students, see M directly proportional to r square. If you understood this, the question is solved here. Is it? So see here. If I write here M1 by M2, na? Hence M1 by M2 means how much here? R1 by R2 whole square. R1 by R2 how much here? 1 by 2. 1 by 2 square. 1 by 2 square. 1 by 2 square how much is coming here? 1 by 4. So correct option is here 1 by 4. Option A is the answer here. Is it? Moving charges and magnetism we are solving here. Okay. Now students, let's see here the further question for moving charges and magnetism. The question is, see, a model for quantized motion of an electron in a uniform magnetic B states that flux passing through the orbit of the electron is nh by e. It's little bit Bose model is also used here. Okay, where n is an integer, h is a Planck's constant, and e is the magnitude of the electron charge that we know very well. After that, what you are telling us, according to the model, the magnetic moment of an electron in its lowest energy state will be how much here, and this they are asking here. Okay, so remember that here first thing, what is this? A flux. What is the flux formula? Flux formula is the B into A. Is it? B. And area. Circle means area how much here? Remember that here, students? Pi r square. Okay. Actually, the formula is the BA cos theta. Theta is the angle between magnetic field and the area vector. But for the circular path, angle between magnetic field and area vector is 0 degree here. Okay. So B into pi r square. How much they have given here? Kindly see here. N h by E. Is it? So nh by E, so r square what will come here? Kindly see here. R square will become here, see, nh by pi, nh by pi r square E. Pi r square E, is it? Pi r square. This is the thing is given. After that, remember that here when it will move in a circular path like this here. No? Like the circular path is this, is it? So for the circular path, remember that here if the speed is v, then one centripetal force will act here, is it? And who will provide the centripetal force? Who will provide? Electrostatic force will provide centripetal force here. Okay. So students, remember that here again, force is equal to the centripetal force here. Okay. So students, just kindly see here. Centripetal force formula, what is this? Mv square by r. And force how much here in the magnetic field? QVB. What is this, students? QVB. So I can write here EVB. EVB. Is it QVB? Charge into velocity into magnetic field. So I can write here EVB here. Okay, EVB. That I have told before also. So what will come here? This V and this one V is cancelled. I can write here, see, V by R is equal to EB by M. No? EB by M. Just make it again. This equation 2, is it? And this equation is 1. First one according to the flux condition. Second one we use here this condition here, magnetic force, EVB, is it? After that, remember that here we have to calculate what? We have to calculate the magnetic moment. Magnetic moment formula, what I have told you, IA. Nah? So current and area, remember that here, okay? Radius is R here, okay? Now next one, if we talk about here the current we are going to calculate. In atomic quantization, the current is given here I equal to Q by T. T means 2 pi R by V, okay? So it will become, kindly see here, students, Q by 2 pi into V by R, is it? So see here, Q by 2 pi, okay? And from here, V by R, how much here? EB by M. Kindly put here. This will become here EB by M, is it? This one we have got here, this one we have got here the current, is it? So next one after that here, current also we have got, everything we have got here, no? So magnetic moment, M equal to NIA, number of turns 1 only, so I into A. Area is given here, students, pi R square. So now kindly put here the value. I, how much is coming here? Kindly see here. Q by 2 pi. Q means, what is this, students? Electron is there, okay? So E by 2 pi. Electron is this, no? So this Q value I will put here, E, okay? So E by 2 pi into EB by M into pi R square value. This R square value. See here, this R square value, NH by pi R square. NH by pi R square B, no? NH by pi R square B. Kindly put here the value here, see. NH by pi R square B, is it? So students, just cancel out what other things can be cancelled. So see here, this pi is cancelled, okay? And anyhow, anything is left. Okay, so which kind of options are there? HE by pi m, HE by 2 pi m, all these things are there here, okay? EB, NH by pi R square B, okay? See here, this B and this B also cancelled, okay? Yes, it is R square value, what I have got here? See here, R square value I have got here, NH by R square value, NH by E pi B, NH by R square value, NH by E pi B. See here, mistake happened here. See here, students, see. R square value how much here? NH by E pi by. See here, R square, na? See, mistake happened. NH by pi EB, na? See here, this one will be pi EB, is it? So NH by pi EB, okay? Then what will happen right here? Now, okay, see, now this E and this E also cancelled. So what this will come here? Kindly see here, students, it will come here N H E, this N, this H E, NHE by what is coming here? 2 pi m here. Is it? So anyhow, HE by 2 pi m. Anywhere it is matching here, HE by 2 pi m here, okay? Option B is there. Now, okay, and when you will see here, na, somewhere it will adjust here, but remember that here, somewhere N will adjust here, okay? So how much coming here? HE by 2 pi m here, okay? Great. Now, students, let's see here. This question is there. Now, see here, this question. EMI question, see. AB is a part of an electric circuit. The potential difference VA minus VB at the instant when current I equal to 2 ampere is increasing at a rate of 1 ampere per second here. Okay. So students, here what will happen that remember that here, see, current is increasing, is it? So when the current is increasing, remember that here, this di by dt increasing means plus 1 ampere per second here. Okay. And current is flowing here. No? Let's take current is flowing in this direction, plus minus battery, and this is plus minus here. Okay. So what will happen that here, we'll use the KVL. So here, students, VA, and after that here minus L di by dt. Okay. And minus 5, and after that minus V equal to IR. I how much is given here? I is given here, see here, 2 ampere. So 2 into R also how much here? 2. Where we reached here? B. We are moving from A to B. Okay. So what this will become here, kindly see here, this VA minus L how much is given here? 1. Di by dt how much is given here? 1. Minus 5 minus 4 is equal to VB. Okay. So when you will simplify this, VA minus VB will come here 10 volt. Okay, just simplify this here. No? 5 4 9, 9 plus 1 10, that will go this side, it will come here 10 volt here. Okay, great. Now students, let's see this question. The question is what's here? Alternating current question. So see, to an AC power supply of 220 volt 50 hertz, a resistor of 20 ohm, a capacitor of reactance 25 ohm and an inductor of reactance 45 ohm are connected in series. Okay, the corresponding current in the circuit and the phase angle between the current and the voltage respectively how much here. Okay, so remember that here this is the RLC circuit. Which kind of circuit is this? RLC. Okay, and this is connected to the battery. This here we can tell here VR, here VL, here VC. This is RLC. Okay, VR, here VL, and here VC, like this here. Okay, so remember that here the thing is given here. If I talk about the impedance is given here always R square plus here which one is more? Inductor is more here. Okay, so XL minus XC whole square here. R square means here 20 square plus XL minus XC how much here students? 45 minus 25 means again 20 square. It will come here 20 root 2 ohm here. Okay, next one, see power factor. Power factor is given by R by Z. R how much is given here? See 20. So 20 by 20 root 2, 1 by root 2, cos phi 1 by root 2. That means phi how much is coming here? 45 degree. Phi how much here students? 45 degree. 45 options are matching. Here 45 is this and other all the places 30, 30, 30. But we can calculate the current also. You know what is the current here students? The current is given here. Remember that here I RMS always is equal to V by Z. Okay. V how much here? Kindly see here 220 volt. 220 volt. Okay. So it will come here, see 220 volt by Z how much here? 20 root 2. Okay, so simplify this, it will come here 11 by root 2 and some 7.8 ampere something will come here. Is it? Can you see here? Okay, so which option is correct here? 7.8 ampere and 45 degree. Correct option is here. Option B is the answer. Okay, B is the answer. This one all we have done here. Now students, let's see this question. What is the question here? The electric field in a plane electromagnetic wave is given by this one. Okay, then the expression for the corresponding magnetic field is how much here. Okay, so remember that here this thing is telling that the wave is traveling along Z direction. Okay, first thing remember that here the electromagnetic wave always travels along E cross B. Okay, from there we'll get the direction here, maybe along X direction, Y direction, and remember that here nothing is mentioned. That means the wave is traveling along we can tell in a vacuum. In a vacuum means with which speed? With which speed? Light speed here. Okay, so C is given by we know always, remember that here, this I used to remember that here, B equal to E by C. Okay, this is the relation. So what will come here? See, electric field is given here what? See here, electric field, see here, this B naught equal to E naught by C peak value. Okay, so it is given here 60, peak value by C means 3 into 10 power 8, so it will come here 2 into 10 power minus 7 Tesla. Any other option? 2 into 10 power minus 7. Yes, here it is there, here it is there. But the thing is that Y or X. See here, here it is given here X direction. That means wave direction, wave travel. Wave travel students in which direction? The wave travel you can see very well. Actually this one we have to compare with the Kx plus omega t. This tells that the wave is traveling along Kx plus omega t means along negative X direction. So see here, wave is traveling along negative X direction. And what is this? This electric field along Z direction. Now, electric field in which direction? Z direction. Remember that here all three will be perpendicular. Wave along X direction, electric field along Z direction, then magnetic field along Y direction. That means where Y? Option A. And electric field and magnetic field in same phase. So here no change. This is the for the electric field, same for the magnetic field, no phase change. Kx plus omega t, Kx plus omega t. Here also students, no use. And see the last question is this from the EM wave. Okay, we are covering all first part here. So see, a parallel plate capacitor made of circular plate is being charged such that the surface charge density on its plates is increasing at a constant rate with time. The magnetic field arising due to displacement current is how much here? So remember that here, students here, displacement current ID between the capacitor plates is given by this always happens due to change of the electric field by the Ampere-Maxwell law. Epsilon naught A dE by dt. Okay, so see here, epsilon naught A d by dt. Electric field is given by sigma by epsilon naught. Okay, so epsilon naught will come outside. Epsilon naught A by epsilon naught, and here d sigma by dt. Okay, so anyhow students, what will constant? What is cancel out? Epsilon what? Epsilon naught cancel. So we can write here displacement current is given here what? A into d sigma by dt. Okay, but in the question they have given here d sigma by dt is constant. See the constant. Okay, so what will happen that here this displacement current will be constant. Remember that here what is this? Displacement current will be constant. Okay, now after that we have to see here the magnetic field. So what is happening that here? See here, this is the circular plate. Okay, and here also the circular plate here like this here. Okay, circular plate here, and here this is connected to anyhow supply. From here it is connected to the supply. We will connect to the supply anyhow. Okay, so what will happen that here? What is given here, students? Here this area is A and this area is also A here. Okay, and remember that here one thing, the displacement current will be uniformly distributed. See, this displacement current will flow like this here, everywhere like this here. Okay, so it will behave as a thick conducting wire. What this will become here, students? It will behave as a thick conducting wire. Okay, and having the center where? The center is this is the center. Thick conducting wire having the center. Okay, and this I can consider that here radius capital R. So you know very well what will happen that here when we are moving from R greater than 0, means R greater than 0 and less than or equal to vary R, less than or equal to R, it will be inside. Okay, and what will happen that here when we are going R greater than R, it will be where? Outside here. Okay, outside. So what happens that here due to this, if I draw here the diagram. Okay, if I draw here the diagram, what it look like here? Kindly see here very well, students. So see, if in case this is a thick wire, okay, I'm just drawing here for your basic understanding. Okay, and after that what will happen that here, if in case this is the center, okay, like this center is this is R, this is B. So you know what will happen that here, this is G, this is smaller equal to capital R. So from center to the surface it will increase and after that it will decrease here. Now this is due to thick wire. So same kind of graph will be applicable for the hair also here. Okay, that means where maximum at the surface, 0 at the center. Now so this graph will see here, kindly see very well. Very simple, this will behave as a water thick wire here. Okay, so you can see very well, non-zero everywhere with maximum at the imaginary cylindrical surface connecting peripheries of the plates. It is, students, so I hope so NCERT Part 1 questions of NEET 2025 you have understood very well. Keep studying, keep going.